you will learn how to create a C++ service server. We will do the exact same thing as we did for Python with all the same functionalities. And for the service interface, so the service definition, we will also use the same one. So Ros2 interface show example interface SRV. So the services will be in SRV and not MSG, add to int. So that's the service we will use, containing a request with two integers, a and b, and containing a response with one integer, which is the sum. So let's create the server. Let's go in our Ros2 workspace in the source directory. We will go to our C++ package, and again in the source directory, we will create add to int server .c++. So this server will receive this request, and we will create a function to process the computation, and the server will then return the sum to the client. So let's edit the file. We will use the template again, add to int server node here, and here we can change the name here, add to int server, like that. Okay, so our code structure is now ready. We can create the server, and first of all we will include the interface. So include example interfaces /srv, and we will get the add to int.hpp. So here again we are using example interfaces, and we've already put the dependency here in our singletlist.txt. Okay, so we don't need to do that again, and also in the package.xml, so it's already here. So let's create the service server. We will first need to declare it, so in private as a member of the class RCL CVP service. So we have a class named service that will create a server for the service, and we need to give the interface example interface SRV and add to int. As you can see, we have add to int, which is the complete service, and inside we have the request and the response. And of course, shared pointer, because as you start to be aware with that, we are using shared pointers with everything in Ros2, and that would be the server. Okay, so now we can initialize the service server, and by using again this create service. So we have a create service function from the node, the RCL CVP node object, that will allow us to create a service, and it will return a shared pointer to the service server. That's why we have shared pointer here. So as this is also a template, we need to give the interface. Okay, and we need to provide two arguments. The first one is the name of the service. So here add to int. So again we use the same one as for Python, and it is a verb, okay, because we are doing a computation. And the second argument is the callback. Let's put that here. So we need to create a callback function for our server, and we will put it as private, because anyway the callback function will only be called from within the class, not from outside. So let's create the callback function here, callback add to int. We will receive two parameters, first the request and then the response. So here the type for the parameter will be quite long, but stick with me for that. So it will be a const example interfaces SRV add to int, and then it will be the request and shared pointer. So we get a shared pointer of the request object from the add to int object, which is itself in the SRV folder, SRV namespace with the example interfaces package, and that will be our request. And we also get the second parameter will be the response. So that will be similar, example interfaces SRV add to int response and shared pointer. Okay, so for every new callback you have with a different interface, we need to replace that, and we always have request shared pointer here and response shared pointer here. And what we need to do in this callback is to process the iteration. So here we want to add two ints and return the sum. So we will simply fill the response sum field. So as you can see, it's a shared pointer, so we use the arrow, and this will be equal to the request A plus request B. Okay, and well, that's it for the callback. We don't need to do anything else. In Python, you need to return the response, okay, but in C++, there is no return type, it's void, so you just need to fill the response object here, and it will be automatically sent to the client. But here, just for debugging, we will add a log, so we can see when the callback has been triggered and what's happening inside the callback. This get logger, and so let's print the computation. It's equal here, and we will have the request A, request B, and response sum, which is already filled from there. Okay, and now that we have our callback, we can put it here, because we still need to fill the second argument of the create service function. So again, we will use std bind with reference to add to int server node and the callback add to int. We also put this to link to this class, and then we need two placeholders because we have two parameters for the functions. Okay, so std placeholders 1, and we need also std placeholders 2 because this will be quite long here. You can also do that using std placeholders 1 and using std placeholders 2. So we just need to put 1 here and 2, and that will work. So if you ever need to put more parameters, then you will have placeholders 3, 4, 5, etc. And we can add a log here, cpp info, to say that the node has been initialized and the server is started. This get logger and service server has been started. And the service server is now complete. So when you create the node here, it will create a service with create service function. So you give the type, you give the name, and a callback to process requests. And when you start spinning, the node will be able to process the request. So when it receives a request, the callback here will be called with the request here, and you fill the response, and then the response will be sent back to the client, etc., etc., for every new call to the service. So now, before we can start it, we will need to create an executable and to install the executable in the cmeclist.txt. So add to int server from the source file, add to int server.cpp, and target dependencies. So target dependencies, add to int server. We will need rcl.cpp and example interfaces. Okay, because the service is from this package. And let's install it. Don't forget that. Add to int server. So let's compile the package. Colcon build packages select with my C++ package. Okay, and in another terminal, let's source the bash rc and let's run the node. Ros2 run my C++ package, and we have a new node add to int server. Service server has been started. So you can check with Ros2 service list. A Ros2 service is yet another command tool you can use with Ros2. And so you've seen Ros2 topic, for example, to handle topics. Well, Ros2 service will do the same thing, but for services. So Ros2 service list, you can see we have the service right here, and we'll be able to call it. So you can call it directly from the terminal. Ros2 service call with the name of the service. Add to int the type, which is add to int here, okay. And we will give the request like that. Let's say A is 5 and B is 8. So the result will be 13, and we get the result right here. And as you can see on the server side, we have the log that is printed when the callback function is triggered. So great, you have a running and working service server in C++. And to emphasize on the fact that Ros2 is language agnostic, actually this is C++ server, and we still don't have a C++ client, so we'll do that in the next lecture, but we can already use the Python client we created before. Okay, so let's do that. Ros2 run my Python package with add to int client, and this will send 3 requests to the server. Okay, so of course it will work only if the service name and service type are identical for both client and server. And it is working. Okay, we have the 3 new lines here and 3 new lines here. So again, you can see that a Python node can communicate with a C++ node, and the opposite is also true. And here, for example, the server has no way to know if the client is in C++, Python, or any other language. And the client has no way to know what is the language of the server. It just knows that there is a server, and it just calls the server. Let's now create a C++ client for the service we've created before. So like I did with Python, I will first write a client with no object-oriented programming that you can run like a script, okay? And then we will see how to include the client in your OOP code. So let's go again in our Ros2 workspace source, my C++ package source, and we create here 2 new files, so touch add to int client, no OOP, okay, C++, and let's create add to int client.c++, which we work on a little bit later. We have the files here. So we will work on this one. Let's still use the template, but we will only keep here. We will only keep the main and not that. And here, instead of using a custom node, we will simply use rcl.cpp node and pass the name of the node here. Add to int client no OOP. And one thing we will remove also is the spin, because a request, and then we will wait until the server responds, and finally we exit the file. So the first thing we need to do is to create the client. So let's use auto client. And we will create it from the node, create client. Okay, so from the node you have a create service to create the server, and you have create client to create the client. Okay, it's quite simple here. So first we need to give the type for the service, and we also need to include the add to int HTTP file, like in the server. So the exact same. Example interfaces srv add to int. And here we have arguments, which is the node service name, add to int, and make sure it is the server, otherwise they will not be able to communicate. We have a client here. What we will do, and what we did for the first, we will wait for the server to be up, because if we send a request and the server is not up, then it will fail. So while the client, we have a function in the client which is wait for service, and we need to give a duration. So let's say 1 second, std chrono seconds 1. So this function will wait for the server. If it's not up after 1 second, it will return false. So then we can continue the while, and we will print something. So you have seen rcl.cpp info. You also have rcl.cpp 1, which has a 1 level for debugging. So again, it is similar. Node get logger. And let's print something, waiting for the server to be up. Okay, so once we are here in this line, it means that the server is up. So we have a client and the server is up. So now we can create a request. So let's create the request. And to do that, we will create a shared pointer to the request object inside the add2int service type. Okay, so we will use std make shared, which will create a shared pointer, and the type will be example interfaces srv add2int request. Okay, so here we have an std shared pointer of the request. We can fill request a, which will be okay, let's say 3, and request b, which will be 8, for example. So now we have our client, which is, as you can see, an std shared pointer of RCL client, and the request also a shared pointer. Now what we need to do is to call the client async send request. So again, we will use the asynchronous way to send a request, because the synchronous way, if you use that, you will get some errors sometimes depending on some situations, and you will not be able to get the spinning for this thread. So we send the request like that, and we will receive a future object. So in fact, we will receive a shared future. Okay, we will receive a shared future of a shared pointer of the response. So now we need to kind of wait on this future so we can finally get the response when it arrives. So to do that, we will do RCL spin until future complete. We need first to give the node, which the node here, for which we want to spin, and the future. Okay, and in fact, we will put that inside a if, because we will check that the result. So this will give a result, and we will check that the result is RCL executor future return code, and we have different code, and we will choose success. So when we get a response inside the future, this will exit, and if it went well, then the success code of the function here will be success. And in that case, we can get the response from the future. So here we will just print it. So RCL info get logger. Let's simply print the result of the computation. We have request A, request B, and to get the response, we will do future.get. And as this is a shared future, we use an arrow, and we can get the sum directly like that. So with this result here, then you will be able to do whatever you want. If you want to process the result from within the client, well, it will just depend on what you want to do in your application. And we can put else here, okay, because if the service call was not successful, then we will not get a success flag for the spin until future complete. So we can put RCL error. Okay, so you have seen now the info level, 1 level, and error level. And this is the same way to write the log, get logger, and let's just say error while calling service. Okay, and the client is now complete. So to recap, we have our node. Okay, we create the client directly from the node using the create client method from the node object. We give the interface, so the service type, and we give the service name, which should match exactly those from the server. Then we wait for the service to be up. So the service will be up when we actually create here the server, okay, from the server code. So then we can create a request, okay, which is also a shared pointer. We can send the request asynchronously from the client, and this will return a shared future. So what we do with this future, we simply spin the node until the future is complete. And when the future is complete, the node will stop spinning, and we get a result. This will be a flag. So if it is successful, we can print the result, and this is how you get actually the response, future.get, and then with an arrow, you can get different fields from the response. And if the service failed, then we will get this error. So let's compile this node. We will add an executable here, add executable, add to int client, no OP from source. From this file, we add dependencies, which will be RCL and also example interfaces. And don't forget that. Okay, now let's compile. Call build packages select with the C++ package. And we get an error. Why? Because let's check that. And in fact, here I used this. So you see, it is an error you should not make here. If you create a node, and if you write with this node from a main, like that, for example, and not from the custom class you've created, then you need to use the node, and don't confuse that with this keyword. And now it should work. Okay, so at least it is compiling. Let's source our bash C. And let's just start the client, Ros2 run my C++ package with the add2int client no OP. And as you can see, we are waiting for the server to be up. So until we start the server, it will continue to do that. So let's start the server. Ros2 run my C++. You can start the C++ or the Python server. It's just the same, okay? So my C++ package server. So we start the server and we get the result. And in that case, you can see that we get the result and then directly we exit the file. We are not spinning anymore with this node, okay? We are just spinning here until the future is complete, which is quite immediate, okay? Because we just return the sum here, it doesn't take long. And finally, we exit the file. We shut down Ros2 communications and we exit the file. So to conclude on that, if you want to create quick clients for your services, then you can create files like that, and this will allow you to customize a little bit more your code if you just don't want to use the Ros2 service call functionality from the terminal, okay? And now we will see how to put that, but inside object-oriented code. In this lecture, you will see how to create a C++ service client, but this time using object-oriented programming, so you can use it with the structure that you already saw before. So what is the problem with what we wrote here? The main issue we have is because we need to use RCL-CPP spin until future complete. So basically, when you have, let's use the number counter, for example, you will start your node and then you will make your node spin, all right? But when your node is spinning inside the node, from inside the node, you can't actually spin again and use RCL-CPP spin something while the node is already spinning, okay? It's just not right to do that. So we will need to find a way to replace that, to actually to make it work while the node is already spinning. And that's what I'm just going to show you now. So we have our add2int clients here. If you don't have it already, you can create the file. And let's use our favorite template. Let's rename that add2int client node. And add2int client like that. Okay, and we have our code structure, which is ready. So what you will do here, you will not directly call the server, you will not create the client directly from the constructor. You will create a function, so maybe we can put it public, a function to call the service, called add2int service. And in this function, we will put all the code to actually call the service. And let's put two parameters, int a and int b. Okay, so then from your from anywhere in your node, you will be able to call that multiple times, and you just need to write one function. So well, the first thing we need to do is to create the client. So that will be the exact same thing as here. We will create the client. Of course, we also need the dependency here, and we create the client. And of course, now we need to rename node with this because we are inheriting from the node object. We have the client. What we do now is the same. We wait for the server to be up, so we can copy those lines here. Let's copy that and here replace node with this. So we create a client. We get a shared pointer to the client. We wait for the service to be up, and now we can create the request. So again, that is the same thing here. Let's put that here. And instead of hardcoding the request here, we will use the A and B that we got from the function parameters. So we have our request object here, actually an std shared pointer of the request object. And now we will also call that. So we get a future object, shared future, by calling the async send request from the client's object that we created here. And we send, of course, the request. And now what will be different is that we will not use spin until future complete. We will need to find another way to wait for the future while the node is spinning. So of course, there is more than one way to do that, but what I propose here is to wait. You have a function directly to wait for the future. So we will wait for the future directly inside this function. And this will actually block this thread, okay? So that's not what we want. We don't want to block the thread, but then we can bypass that simply when we call this function. We will not call it directly, we will call it in a new thread, okay? So we wait for the future, we block the thread, and when we call that, we create a new thread. So let's see how to do that. We will do future.get, and future.get will wait, so it will block until we have a response for the future, okay? And it can also throw an exception, okay, if there is any error. So we will have the response, auto response from the future get, and we will put that inside a try-catch structure. So try-catch, we put that here. And we will catch a const std exception, a reference to the exception. So let's deal with the exception first. You can do RCL-CPP error, this get logger, and let's say the service call failed here. So, okay, I forgot that. So future get will pause the program here and wait until a response has been given to the future. If it fails, it will throw the exception that we catch here. And if it succeeds, then we get our response, okay? And the response is, as you can see, the add2int response. It is actually a shared pointer to that response, okay? Always a shared pointer. So now let's print the result. So at this point, you can do whatever you want with the result. It depends on your application, and let's print it. this get logger, and we can again print the result of the operation. So A, B, we directly have A from there, A, B, and response, a row sum. And the function is now complete. So, quick recap. So we create the client with the type and the name for the service. We wait for the server to be up. Then we create a shared pointer to the request. We fill the request with whatever we need, and we send the request to the server. This will give us a future, and we wait on this future until we get a response or an error. So if you directly start this file, what will happen is nothing, because you didn't call the function right here. So what we'll do is we will call that to actually call the service. But as I told you, we will need to call it in a different thread, because let's see what will happen if we directly call it from there. If I do call add to ints with 1 and 4, what will happen is the program will start. We initialize Ros2 communications, and we start the node. So we go here, we call this function. That will succeed. We create the client, we wait for the service. If we start the server on another terminal, this will pass. We create the request and we send the request. And now here is the problem. We wait for the response with future get. So this will block the thread here. And that means that the function will not exit. And the constructor here will not exit. So we will still be in that line of code. And the spin, this line will not be executed. So here we actually need this line in order to get the result from the future. So as you can see, we need to start it in a different thread so we can continue the execution. And so this constructor can exit, and so we can finally call spin on the node. So what we do here is we will create a new thread, and let's create a thread object here as a member of the class. std thread, let's call it thread 1. And we can just do thread 1. We can just put std thread like that, and we will need to give a function. So to give a function here again, to call this, we will need to use std bind. So reference to the function, as you can see, it's always the same. Std bind is not that hard to use. Call add to in service this, and we have two arguments to give here. And for the callbacks, you have seen that we are using placeholders, because we don't know yet what will be the parameters. This is just the placeholders, as the name suggests. Here we can directly pass the arguments. So here 1 and 4, and that we call the function here with 1 and 4. And we can remove that line. So make sure that your thread object is a member of the class, Otherwise it will go out of scope here, and then we get an error. So we save the file, and what will happen here is that when we create the node, then this will start a new thread with this function, and it will directly exit, so we can start spinning. And when we get to that point, the node will be spinning, so we will get the response, and we get then the result we want. Let's compile that, and we'll put it here at executable client dependencies. Add to int client with CVP and example interfaces. Great. We add here add. So the order does not really matter. Here I just follow the order for the calls. When I create something, I just put it after the other one. And let's compile again. So we already have our server, which is running. We will not modify that. And here, instead of calling the add to int client no OOP, we will call the add to int client, and see what we get here, and it's working. We have the server here. The callback was triggered, and the computation was made, and then the response was sent to the client, and we can see the response here. And as you can see, the node is still spinning. I can kill it, and I can start it again. Now, if you want to, let's go here. If you want to send multiple calls to the server, what you can do is you can implement a thread pool. That is quite common in C++, so you can do that on your own, as it will mostly depend on your application, like how you want to manage different threads and different calls to the server. Then I will leave that up to you if you want to call multiple threads. But for example, here, what we can do as a very simple solution is to create an std vector of std thread. Let's call it thread like that. I will remove that. And then instead of doing that, we will do, so here, I will simply call threads, and you will do pushback to add a new thread, and here simply put that inside the pushback function. And what you can do now is to add a new thread to the thread pool with different parameters. And if you start the program again, so you will need to compile it first. You can start it, and you can see we have 2 requests and 2 responses, and it is working on the client side and the server side. So congratulations, you can now write your own complete service server and client using OOP and using directly a non-OOP solution. And it may seem quite difficult for now, but don't worry, because that's actually will be used as a template. So you will be able to use that as a template. You will always do the same thing, okay? You will just need to actually replace the interface, the name of the server, and the request. And of course, to change what you want to do with the result, but the rest of the function will be exactly the same for every time you want to send a request to a server from a client in your code. In this lecture, we will review together how to debug your Ros2 services with command line tools and also with Ros2. So you can use Ros2 service. If you press tab twice, you will get all the commands that you can use. And in fact, you've already seen the most important thing is Ros2 service list and Ros2 service call. So if I do Ros2 service list here, of course, there is nothing. I will start the server we created, Ros2 run my, let's start the C++1, add to int server. So I start this server. If I do Ros2 service list, I will see all the services for all the nodes in the graph. As you can see, we have a few services already. All those ones are for parameters. Okay, we've already saw that before. And this one is the one that we created in the code. So you can also find that directly with Ros2 node list. You will see that you have this node. Then you can do Ros2 node info add to int server. And in the service servers, you will see you have the add to int with the interface. So from the node name, you can find also the interface. And when you have Ros2 service list, when you have the name of the service, you can also find the interface with Ros2 service type and the name of the service. And you can see you need to use example interfaces SRV add to int. And then you can use Ros2 interface show with this name. And you have everything you need for the request and the response. So that's pretty much it, what you can do with the Ros2 service command line tool. And of course, you can call directly the service with Ros2 call, Ros2 service call. You put the name of the service, add to int, you put the type of the service, example interface, etc. And then you put the request. And you also have auto completion for that, but if I press tab twice, you can see if I press A and tab, well, you can see it's not that convenient, and you will often have errors when trying to modify that kind of stuff. So that's why when you use the Ros2 service call, I recommend you directly do that. You create your own request with curly brackets. It's not that hard, so A and B. Okay, and you get the response. And now you can also use the RQT plugin. So let's launch RQT. So, okay, you will have that, you will have nothing. You can go to plugins and services and service caller. And that is basically a graphical interface just to call services, which will be quite useful when you want to do Ros2 service call, but when you have many things in the request. Because here the request is quite simple. It only contains two fields, which are primitive data type, but of course you will guess that later on we'll have more complex requests. So you can refresh here and you can see the different services you can call. So here you have the top, well actually it's service here, I don't know which topic. You have the type and you can choose the parameter here. Let's say A is 5 and B is 6. Then you can call the service from there and you get the response here, which is 11. And you can see the service here was called from the server logs. And one other thing you should know is that if you go to node graph, you can see the node, but you will not be able to see the services from RQT graph, only the topics.